Okay. Math 87, lesson 98, page 603. We got scale and scale factor. Scale and scale factor. We're not talking about the size of a fish. We're not talking about snakes. There's scales. Scale is, I don't even know how to explain this exactly. When I was a kid, I used to build models all the time. Say, okay, on the model, let's say I built a model of an airplane. Okay, so my little airplane looks like this. Okay, and here's okay, here's my airplane. Here's the propeller. Now this is a model, okay? It's small enough that I can hold it. Okay, let's say that my model is 12 inches long. Now the real airplane is not 12 inches long. The real airplane would be, let's say, I don't know, let's call it 60 feet long. I shouldn't use those little marks here. Okay, the real airplane is 60 feet long. See, I can't build a 60-foot airplane, but I can build a 12-inch airplane. Okay, what the box has on the end of it, it'll have a scale factor. It'll say a 1 to 32 model, or a 1 to 24 model. Okay, this is the scale factor right here. Okay, so what we do is this. Let's say I'm building a model airplane. Let's use the 132. That's pretty normal for, it's 1 to 32. All right, that's pretty normal for models. So what I do is I'm going to set up a ratio. Okay, so here's the model and here's the actual. Okay, so is this how they're going to do it? Let me just make sure. Let's not do it. Okay, so the ratio here is 1 to 32. This is the model, and this is the actual here. Okay, now what I have is I have a measurement. Okay, so this is the ratio, and this is the measurement. M-E-A-S-U-R-E. This is the model, and this is the actual airplane. This is the real, this is the model, this is the real one. I spelled it wrong probably. Ratio. Just trying to show you. So this is a 1 to 32, 1 to 32. Now on my airplane, if the length of it is 12, on my airplane it's 12, okay, it's going to be 12 inches. Does that make sense? What I probably ought to do is let's change, instead of 12 inches, let's call this 1 foot. Okay, so I have 1 foot. Otherwise I'm going to end up with inches here, and there's a lot of them. Okay, so how long is the airplane? If my ratio is 1 to 32 and I have 1 foot here, then it's going to be this times this divided by this. That's going to be 32 feet here. Okay? If I was going to build a bigger model, let's say I have an airplane that is 5 feet long. Okay? And it's the same scale here. Okay? I just changed my numbers. 1 to 32 still here. I put 5 feet here. Then it's 32 times 5 divided by 1 here. 32 times 5, that's 1, that's 15. Then the airplane itself is actually 160 feet long. Okay? Let's say I still have the same thing here, but instead of on the model, I have the actual airplane. And its wingspan from here to here, let's say, is 200 feet. Okay, 200 feet. So this 200 feet is not going to go here, it's going to go here. All right, so what I'm going to do is I'm going to go this times this divided by this is this. So I'm going to have 200 divided by 32. 32. 3 goes into 20. Let's say about 6 times. Let's see what happens with that. I think that's going to be too much. Let's go 5 times. So 32 times 5. That's 10, 15, 16. Okay. 32 times 6. That's 12, 18, 19. That's closer. Okay. So if we go 6 and we get 192 and you subtract. So this is going to be 8 right here. So it's 6, it's going to be 6 feet and 8 over 32, which is 1 over 4. Okay? So it's the model is going to be 6 1/4 feet long. See how I do that? Going back and forth like that? Okay? All right, so what you do is you set up the scale. You set the scale, the ratio here. And whatever they say here, if they give you the model, it goes here. If they give you the real, it goes here. And you cross multiply to find what you have. Okay, it's a ratio. Okay, now scale factor is, let's go back to our triangles over here like this. Okay, we have a bigger triangle over here like this. And these are similar triangles. We've got 16, 20, 20 and 25. And what else? 12 and 15. So if these are similar triangles, there's going to be a scale factor. What that means is there's going to be something. I can multiply something times this to get that. This times something is that, okay? So you just set it up, and we're going to find out what the factor, the multiplication factor is. So 20 times x equals 25. So how do you get rid of this 20? How's it connected to the x? It's multiplication. Opposite of multiplication is division. So we're going to divide both sides by 20. Okay, that's 1. X equals. So if we have 25 divided by 20, we put our decimal, throw a couple of zeros. 20 goes into 25 one time. Excuse me. 20 goes into 50 2 times. And 20 goes into 100 5 times. So our scale factor is 1.25. That means if I take 20 times 1.25, I get that. If I take 16 times 1.25, I get that. If I take 12 times 1.25, I get that. Instead of writing x here, if you do this, scale factor. Scale factor. Scale factor is that right there. So you want to find the scale factor, okay? No matter what is over what number on this triangle, I can always find the one over here if I know the scale factor. This is what I multiply from here times this gives me this. This times this gives me this. This times this gives me that. Okay? All right, let's see here. Let's do something a little bit different. We're going to run out of time here. I have 2 cubes, okay? I have a big cube, a little cube. All right, I'm going to forget this noise. I'm just going to put my numbers on here, okay? I have another cube over here that's larger. What we're going to do here is this. Cube A, these are cubes. All these are the same. This side over here is 1. On this one here, that means this is 1, this is 1. They're all 1s, okay? On cube B, okay, on cube B, the sides are going to be 2. That means this is 2, this is 2, this is 2, because it's a cube. All of them are the same. Okay, so now our scale factor from one to the other, okay? 1 times scale factor equals 2. Okay, so the scale factor is 2. 1 times 2 is 2, 1 times 2 is 2, 1 times 2 is 2. Wow. Let's do this. This is just retarded. Let's just change some numbers on here. Okay, instead of having a cube, I'm just going to have a rectangular prism, which is what these look like more anyway. Let's just do this. 2, 3, 4. So this is 2, 3, and 4. Over here, this is 6, 9, 6, 9, and we're going to say 12. Okay, so we're going to say these are similar. We want to know what the scale factor is from one to the other. So let's take this here. 3 times scale factor equals 9. I'm going to go from here to here. Okay, so what do? Is I divide by 3. So the scale factor equals 3. This divided by 3 is 1. This divided by 3 is 3. So the scale factor, the measurement from here to here is times 3. 2 times 3 is 6. 4 times 3 is 12. Do you see that? Okay, so our regular scale factor here. Now, if we do area, let's say we took the area of this face. The area of this face is 2 times 3 is 6. The area of this face is 6 times 9 is 54, I hope, because you're supposed to know your multiplications, right? So 6 times 9, 54. There we go. So watch this. Let me just show you this. What's the scale factor between this and this? Okay, 6. The scale factor equals 9. Okay? Between the areas. Area is always squared. Area is always squared, okay? So the area here is 6 feet squared. Let's say these are feet. All right? The area over there is 54 feet squared. So our multiplier is times 9. Do you see that? Now, our distance from here to there was 3. Okay? On area, the scale factor is 9. Now, volume is this times this times this. Okay? 2 times 3 times 4. 12 times 4. The volume of this is 12 times 2, 24 feet cubed. All right? Now, I'm not going to try to do this one in my head because I can't. But if I take this times this times this, okay, over here, our volume is 6 times 9 times 12, 648. Okay, and this is feet cubed. Now, if we want the scale factor between the 24 here and that, so we go 24 times scale factor equals 648. And we take this 600, divide here by 24. Divide here by 24. Those cross cancel. And if we take 648, and I'm lazy right now, divided by 24 equals scale factor right here, 27. Now watch. 27, and we're cubed. Okay? The scale factor over here is 9. The scale factor over here was 9, and we're squared. Okay, 9. The scale factor here is 1, and it's just exponent of 1. So for area, since area is squared, distance is 3. That's the scale factor. Area is squared. If I take and square that, that's 9. If I take volume, same number, and I cube it, it's 27. So if the scale factor between the length of the side is 3, the scale factor between the area is 9. And the scale factor between the volume is 27. Okay? So if I have a scale factor, let's say the scale factor between two objects is 4. Okay? Just the distance. Then the scale factor for the area is going to be this. And the scale factor for the volume is going to be this. Okay? This is how much I'd multiply times each side to get the side on the other one. For the area, I'd multiply it by 16. For the volume, I'd multiply this side by 64. Okay? See what you can do with that.